So we want to find the inverse Laplace transform of 1 over s to the n, where n is a positive integer. So another way we'll write f bar of s is equal to 1 over s to the n. So as n is an integer, this has no branch cuts. So this is very straightforward to find the inverse Laplace transform of. First note, obviously this has a pole of order n at s equals 0. So f of t is simply, well, there's only one residue, so there's no sum, is the residue of e to the st over s to the n at s equals 0. So probably the easiest way to do this is just to consider the series of this. And if we think about the series, what the series does, e to the st, of course, is 1 plus st plus st squared over 2 factorial plus, and then the general term is st to the r over r factorial. So if we're dividing by s to the n, what we want is the coefficient when we get coefficient of 1 over s. So divided by s to the n, that's basically going to be when r minus n is equal to minus 1. Or in other words, r equals n minus 1. So when r equals n minus 1, the coefficient we get is simply t to the n minus 1 over n minus 1 factorial.